Hello, I'm Aaron Solomon, with Frontier Fire Protection based in sunny South Florida. We are offering a series of educational webinars on various fire and life safety industry topics, and we are thrilled to have Rodger Reiswig, Fellow and VP Industry Relations with Johnson Controls, to be our guest speaker in the series. Hello, Rodger. Thanks for joining us.
Hi, Aaron, and thanks for having me. Glad to be here.
Thanks. Appreciate it. So today's topic of testing and inspections of fire alarm systems will cover some of the most important points of maintaining your existing fire alarm system. The majority of us are very familiar with fire alarm testing and inspections, but really, other than code requirements, why do we need to test fire alarm systems?
Yeah, that's a good question, Aaron. And as we go through this today, for a little bit here, we'll talk about inspections and the needs and some of the tools that are available. But why do we need to inspect, test in fire alarm systems? Well, one big thing is code requires us to do that, and we just don't know if things are going to work when they need to work. So we need periodic inspections of things. In our life safety code, whether it's NFPA 101 or the building codes, the building owner is required to have their systems inspected, all their life safety systems inspected, and they push us into NFPA 72 for fire alarm on frequencies, methodologies, and how they need to be done. But when we look at life safety systems or fire alarm systems, you can't always tell if they're fully functional just by looking at them. You walk by and hopefully the green light's lit and everybody's happy. And with any electronic, component, things degrade over time. They get contaminated, dust, dirt, maybe a little bit of corrosion. Could be vandalism even. Somebody did something to a piece of equipment and you had no idea. I remember when I used to do inspections in the field, there were several times I would go to a building owner and show them, hey, this was something that happened, whether it was vandals or maybe somebody just accidentally did something and they were totally unaware that that piece of equipment got damaged. And what we're wanting to do, though, is when we test these systems, is we want to reduce false alarms or nuisance alarms, and we want to improve the reliability of the system. If there's a system that's constantly going off, people might not trust it. And we want to make sure that the owner, the contractor, all the people that are involved, that their risk and their liability is also lowered. And lack of maintenance and testing is the leading cause of failures of fire alarm systems. We see it over and over again, and the Automatic Fire Alarm Association has talked about this. There's been studies from University of Maryland. NFPA themselves have done research to show, and the leading cause is poor inspections, poor maintenance of systems. The picture on the right, it's floated around the internet for a while now. I just like that one where people will say, yes, boss, I check that valve every year, no problems. And here you have branches growing through the thing because people just don't do proper inspection and testing.
Absolutely.
But all electronic components fail, not including, when we talk about loss of power, things like that, everything's going to fail at some point. And if we take as an industry average 4 failures per million hours of usage as our kind of our design failure rate that can be permitted, or mean time between failure rates, and so it's not that many if you look at it. But then when you kind of extrapolate it a little bit and you say, okay, if it's 4 failures per million, what does that mean for me in the life safety world? And here we got an old smoke detector, and if we take 3.5 failures per million hours, that's 3% of all detectors will fail in a year. And that's probably about what we see, as an industry, and not manufacturer specific, but just as an industry. When you go in and test a system, you're finding 1 or 2, 3 devices here and there that are failing in systems. And so if you pull that out in 10 years, that's 26% of devices. Almost 40 or a little over 45% in 20 years and over 60% in 30 years are failing. Then we need to just check and verify these things. So how long does a building last too is another question when we get into these. Our buildings are being renovated every 20 years, 30 years, and a lot of these pieces of equipment are being changed, modified, and pulled out. So when we look at NFPA 72, starting, in 2010, the document was restructured, and now the testing maintenance chapter is chapter 14. But as we look at this, Aaron, you and I were talking earlier about some of the things that we see that are coming up more prevalent. We have impairments, we have deficiencies. We have recommendations that are out there. Who's responsible for this? There's this new thing for a test plan that's required, and the formats that we use, and voice intelligibility. So these are kind of some of the things I wanted to highlight on.
Right. And of course, as you know, there's times when we are out there doing an inspection and we come across a deficiency. So really, who's responsible to make sure that it gets taken care of, and how quick should it get resolved?
Well, and that's a really good question, and that's something that the 72 committee has been wrestling with. Aaron, as you know, I spend a lot of my time with NFPA 72. I'm on the correlating committee as well as several of the chapters, and I also serve on the Standards Council for NFPA, and we do a lot of work trying to define, understand about these deficiencies, who's responsible. So when we look at the code in chapter 14, section 222, it talks about impairments and deficiencies, and it says the system deficiencies shall be corrected. And it's kind of interesting. Up until the 2010 edition of 72, the document did not say that you had to repair the deficiency that was found during the inspection. It just said if you found something wrong, document it and provide that to the building owner. But nowhere did it say go fix what you found was wrong. So system deficiencies shall be corrected, and that's the building owner's responsibility. It's their building. And if I'm out there doing the inspection, if I'm not able to correct it at the time of the conclusion of the inspection, then the owner shall be notified within 24 hours in writing. And that's something that's relatively new in the code as well, starting in 2010, because now we have a time frame. So it's no longer I take all the documents back to the office, I fill it out, I have somebody put it in the mail, and maybe I'll get it to them in a couple of weeks. They've got to know within 24 hours, because there have been instances that have occurred where a deficiency was noted, the building owner wasn't aware of it in time to get it fixed, something happened in the building, and we had injuries or other things that had happened in the facility. So NFPA is now putting a time frame on that. But it all goes back, though, to the building owner's responsibility. It's their system. They're the ones that are required to make sure that their buildings are maintained properly and safely. So, and when we get into delegation of responsibility, there were some people that were asking to the committee saying, okay, well, what about if I own a building? I live in Boston. And my office is in Boston, but I might have a strip mall in Orlando, and I don't go there every day. Can I delegate that responsibility to somebody locally for me to do that? And you could do that. So in 14232, where am I able to do it? Property owner shall be able to delegate authority and responsibility to the occupant. So now if I have a strip mall and I have Aaron's coffee shop in the strip mall, I can tell you or ask you, Aaron, can you be my responsible person? Can I give you the authority to act on my behalf for the life safety systems in the building? And if you accept that, so that's how that can transpire, because there were many issues that were coming up with these major companies owning buildings all throughout the United States and not physically being there. So how can I delegate that responsibility? It's not really saying I'm delegating the responsibility to the inspector or the testing company, but it's to one of the occupants of my buildings. Now, this is something that's new in NFPA 72 starting in 2013 edition, a test plan. And there's been a lot of cases, Aaron, where people have not understood exactly what they're getting inspected in their facility.
Mm-hmm.
If I have a fire alarm system, for example, and it's connected to an elevator, are you going to test that the fire alarm relay is activated? Are you going to verify that the elevator recalled? Are you going to work with the elevator company and do that? If I have 100 smoke detectors and you're going to come out to my building twice a year, are you going to check all 100 in the first time you come and then other devices the second time you come, or 50-50? And for that matter, even what devices are you going to be testing? How are you going to test those devices? Are you going to use smoke? Are you going to use the fire alarm control unit as a test tool? So NFPA 72 said we need to create a section that requires inspectors, companies, to create a test plan, something you can give to the building owner or their representative, a clearly established scope of what you're going to be doing, how you're going to be doing it, how you're going to document those results, and then give them to the building owner. So I think this is something that's very important, and I see a lot of companies missing this, and a lot of building owners missing the ask for this as well.
Mm-hmm.
So, and then also in 72 and 2010, the tables, the frequencies, methodologies have been incorporated now into 2 tables. So we have the tables for testing, the methodology, how you do it, and then the frequencies were all combined together. And then we have the visual inspection as a separate table. But now we get into the components. So if it's a smoke detector, well, what kind? Is it a duct smoke? Is it an area smoke? Or what have you? And then how often do I have to do it? And then what tools or what methodology do I use to make that occur? Chapter 14, this is intelligibility. Intelligibility was really high, Aaron, on our discussions in late 2000, 2005, 2007 time frame. And it was kind of like a pendulum was swinging with this intelligibility requirements. NFPA 72 kind of swung the pendulum way to one side and said, you need to do intelligibility testing everywhere, all the time. Well, intelligibility testing, basically we have for our speakers in our buildings, we have audibility. Can you hear what's being said? And then you have intelligibility. Can you understand what's being said? And that was the part that we started to miss, or we were missing in NFPA 72 for many years. And now as these voice systems are becoming more prevalent, it's important that the occupants not only hear what's being said, but understand what's being said. So voice intelligibility requirements now say you need to follow the requirements in Chapter 18, Notification Appliance Chapter. But instead of having a quantitative measurement, a prescriptive measurement using a meter going to every speaker, the code actually lightened up on that and says intelligibility shall not be required to be determined through quantitative measures. Quantitative measures, if you choose to do that, you can use Annex D to give you guidance on how to do it, but it's not required. Because you had people going into a facility and they were taking a meter and they were listening for the intelligibility sound coming out of the speakers, and you would get to a certain point and you say, okay, it passes. You would move a few feet and all of a sudden you would say, oh, it didn't pass, you failed. You got to add more speakers or do something different in the system. It was really becoming an overburdening thing.
Mm-hmm.
So now it's kind of up to the AHJ. They walk into the building and they say they can listen to it, and the AHJ can say, you know what, sounds intelligible to me. It passes, we all move on. If there's questions where not sure it's really intelligible, then you can go to Annex D. But that's kind of been eased up a lot, and I think it's helped a lot in our industry. It still recognizes that intelligibility is important, but it doesn't overburdening for the requirements for testing. Something else we need to do that I think I see people missing is alert people that we're going to be testing the building. Put some kind of signage out. Tuesday, April 27th, for example, from 9 to 3:30, we're testing your fire alarm system. And then even more, what I hear people or don't see people doing is in 14.2.4.2. At the conclusion of the testing, those people that you previously notified shall be notified that testing has been concluded. So you think about it, you're like, well, what's the big deal with this one? Well, it's 9 o'clock, you tell everybody we're testing the fire alarm, please disregard. But Aaron, we got done early. It's 12:30. We got finished everything passed, we gave it to the report out, we're great, and we all leave. But we told them it's tested until 3:30. Now 2 o'clock comes along and they hear whoop, whoop, get out of the building. And everybody's like, oh, they're still testing the fire alarm. No big deal. So it's really important that we notify people after we're finished. Almost as important as when we tell them that we are going to be testing. So then we get into, for fire alarm systems, we talk about reliability. So what are we talking about when we talk about reliability? What do we need to do? Well, we need to make sure that systems are properly designed and that devices are being placed where they should be placed. If I have indoor devices that are being placed outside, is that proper design? Do I have enough devices to alert the occupants of a building? Do I have enough smoke detectors, for example, as required by code? So in 2010 of NFPA 72, all of the qualifications in 10.5 were revisited or revised by the committee to better define what the requirements are for designers, installers, maintainers, etc. So in 10.5.1.1, Aaron, we had fire alarm system and emergency communication systems, mass notification. Plans and specifications shall be developed in accordance with this code by persons who are experienced in proper design, application, installation, and testing. Okay, so now you set the premise out there, right, Aaron? We have people that were telling you they need to have experience or have some type of credentials to do that. And then you might say, well, what kind of credentials? How can we find out? Or how can I prove to you that I have these? So system designer in 10.5.1.4 can prove those by having qualifications or certifications. If they're registered or licensed by or certified by a state, could be a PE stamp, a license, fire protection engineering license. People who are certified by a nationally recognized certification organization. Probably the biggest in the U.S. is NICET, and I know you have a lot of people that are NICET certified on your staff, Aaron.
Yeah, absolutely.
And then people who are factory trained, and I know you're big on training as well to get your people trained.
Yeah, absolutely. Yeah, all of our technicians, installers. When I say technicians, I mean our service technicians as well as our management team. Everyone goes through a rigorous training when it comes to our products, and even our licensed engineer on staff, full-time licensed engineer Jeff Kastner, who's on the team to review and stamp all of our fire alarm drawings prior to submittal for permit, which is great. It kind of leads into this exact topic we're talking about right here.
No, that's great, and you have people on staff, your own in-house people that do that. You don't farm it out, which kind of hats off to you on how you guys apply that. When these qualifications were added to the code, this was more to give what we call in the code world teeth to the AHJ, authority having jurisdiction, where maybe you submit for plans review a system and they look at it and they're like, this must be the first time you've done this because this is horrible. What they're able to do though is respond back and say, here's all the write-ups, all the changes, the red marks that you need to do, but also according to 10.5.1.4, show me how you're qualified to design systems. And this is able to flush a lot of that out.
Right.
And then for a system also to be reliable, it's got to be properly installed. And this is kind of an older picture, but it just kind of tells a big story right here. You have a fire alarm, strobe, and a horn. You got a smoke detector, exit sign, emergency lighting, regular lighting. All of this in this little tiny real estate space. That's not properly installed. And yes, on the plans, it might have said, put the device here in this corner, but as an installer, you should take it upon yourself to bring it to somebody else's attention and say, look, this doesn't make a whole lot of sense how I'm doing this. We need to revisit this area. So fire alarm system personnel in 10.5.2.1, we have qualifications for them as well. You're going to be doing installation. You need to be qualified to do that. And then just like the other one, you need to be either licensed by the state. You could have an electrical license, personnel who are certified by a recognized organization like NICET, or people who are factory trained and certified for fire alarm systems. And then another one for systems to be reliable, it's got to be properly maintained. We kind of look at these pictures and we kind of maybe laugh a little bit, and it's kind of tongue-in-cheek here, putting tape over the device or a glove over the device. But it is amazing when you go into a place and you find a smoke detector that's got tape on it, and you're saying, hey, did you know that you had tape on that smoke? Oh, yeah, we did renovations about 5 months ago, and I guess they left the tape on.
Yeah.
Well, that's another reason why we need to do inspections. Or the glove thing there that you see. It's like, oh, yeah, we had a welder come in. He was doing some work. They threw a glove over top of the smoke detector and never pulled it out. But, and something that NFPA has wrestled with a little bit is trying to understand more about why people don't leave a building or leave as quickly as they should when they hear alarm sound. And some of the things that the Research Foundation, a wing under NFPA, the Fire Protection Research Foundation, has found is people don't always believe that the alarm is real. And if they don't see flames or smell smoke, then they assume it's a false alarm. And false alarm, nuisance alarm, we get into those, attributes. In NFPA 72, we no longer call it a false alarm. Everything now is a nuisance alarm, and then we have different definitions of those. So we have unwanted alarm, an alarm that occurs as a result of some type of a potentially hazardous condition. Malicious alarm, where a person acting with malice. A nuisance alarm, where a device is going in based on stimulus or condition that is not, of a potential hazardous area nature, whether it's steam from a stove or maybe dust, contaminants. And unintentional alarm, somebody did it without malice, kind of on accident, or just kind of maybe messing around with it. And when you look at this and you start to say, well, why do we have all these definitions now of different types of nuisance alarms? And kind of inside baseball a little bit, the INFRS, National Fire Incident Reporting System, that all fire departments in the United States, whether they're paid or volunteer, they need to fill out this form. I went out to the facility and I observed a sprinkler head went off, a smoke detector was activated, or what have you. If the fire alarm went off, but there was not a real fire, there was one box for them to check: false alarm. And when we we did this with the Automatic Fire Alarm Association and the University of Maryland, we and NEMA got involved, and a lot of reporting was done, and it was over, I think, close to 250,000 reports were reviewed by University of Maryland. And the high account of just people checking the false alarm box was just off the scale. So the U.S. Fire Administration got involved, and we as a group went to them and said, we would like you to change so it doesn't just say false alarm. And they said, we can't change those boxes until you put something in the code that we can reference. So that's why these are in here. I'm a why guy. I want to understand why things got added to the code. But that's why it now says unwanted, malicious, nuisance, and unintentional, because now as a first responder, once the INFRS document gets updated, I now have these various boxes to check. So there's rhyme and reason why things happen. And unknown alarm, sorry for the last one, where you just you're not sure exactly what affected it or what the cause wasn't easily to be identified. So, Aaron, we kind of were talking a little bit about this, about how NFPA 101, the model codes, the ICC, International Code Council, they're the ones that require the building owner to have their fire alarm systems inspected, and then to do that per NFPA 72. Same with sprinklers: inspect your sprinkler system per NFPA 25, fire extinguishers, NFPA 10. These codes that we use in the US are what drive us to get to those places. So in NFPA 101, I have an older edition here, 2012, but a fire alarm system required for life safety shall be installed, tested, and maintained in accordance with the National Electrical Code, NFPA 70, and NFPA 72, unless it is an approved existing installation which is permitted to be continued in use. So this is the governing overriding documents that once my state or municipality adopts, it drives me on what I need to do. And then within the 2012 edition of 101, it will tell you which edition of NFPA 72 and the NEC to use. In the I code, the IBC, International Building Code, a fire alarm system shall be installed in accordance with the provisions of NFPA 72. So even the I codes, the International Code Council, and NFPA, they're competing organizations, if you will. They're two different organizations. There's some confusion about that. I know with some people, they might think that they work together, or one complements the other. And they're really separate. You're either, we talk about, are you an NFPA 101 state or an area, or are you an IBC or an ICC state or an area? But the International Code Council, they only write codes. They don't write standards. So then they reference back to NFPA for those standards. So what are some of the problems that we find? We kind of laugh at them and joke at them, but you see, pictures, these are real life, events. As I travel around the country, you see some of these pictures. Aaron, we talk about
Okay.
smoke detectors and proper maintenance and installation. Um, NFPA has found that, and as we showed this early on, that lack of proper maintenance and taking care of your system is the leading cause of nuisance alarms in our systems today. And one of the big things that we could identify or at NFPA was able to identify was during construction, the dust, the carpet, fires, things that just are in the air, it contaminates smoke detectors. So you might not have a problem day one, but then you start to get nuisance alarms 7 months, maybe a year and a half down the road. Or you get dirty detectors and the customer, the end user is like, what's wrong with your system? Your system is going into alarm all the time. Or it's always telling me the devices are dirty. It's a new building. What's happening? So to help with that, 72 now says in chapter 17, initiating device chapter, in 7.1.11.3, where detection is not required during construction, detectors shall not be installed until after all the other construction trades have cleaned up. So it's trying to help to alleviate that problem. Now, there are times where a fire marshal might ask for a smoke detector to be installed because you want to start to occupy part of the building or
Hmm.
maybe start to bring in some materials. And it's not uncommon for them to say, sure, that's fine. I want smoke detectors to be installed now. Well, that's a different story. But by and large, we shouldn't be going in while the trades are still cleaning up and doing things and put our detectors up on the ceiling.
Right.
So ambient conditions also cause nuisance alarms, unwanted alarms, and we need to be aware of where we're putting our devices. In 17741, where you have spaces that are served by air handling systems, detectors shall not be located where airflow prevents operation of the detector. So, excuse me. So we will talk about this and we'll look at it and we'll say, hey, the smoke detector is going to be getting dirt from the diffuser into the detector. You're going to make that detector dirty. But also what happens is, as smoke rises from the floor, the air diffuser can push that smoke away from the detector, and the detector may never go into alarm. So that's another issue. So we have two problems with this type of a scenario. You're going to contaminate the device, and also it might never go into alarm. And then in the annex, detectors should not be located in a direct airflow of closer than 36 inches from an air supply diffuser or supply. Um, so it gives us a little bit more guidance. That 3-foot rule where we say a device needs to be at least 3 feet away.
Right.
And here's one we see all too common, Aaron, as we're out working in the construction field. You see people,
Yeah.
whether they're sanding, vacuuming, you got dust everywhere. The people are wearing masks. This was taken before COVID, so they're wearing masks because of the contaminants in the air. And the smoke detector doesn't have a mask. All of this stuff just goes right inside it. So
Right.
this is what we're trying to avoid.
Yeah, and we see that a lot because one of our major focus in our business at Frontier is working with our general electrical contractors. We're doing a lot of new construction work, and we come across this. I mean, we have a couple of projects we're in the middle of right now where there's multiple trades, a lot of dirt, like you see right here in this picture, and it's a perfect example. So, and I'm glad we're able to hit on some of those points of some of the things we should be aware of, and not only for us, but as well as the other trades that help us make sure we don't have problems with the fire alarms. That way, the general contractor and the owner can get their CO once we're completed.
Exactly. And like I say, you're alleviating problems down the road because it's probably not going to be an issue the next day, the next week, or even the next month, but months down the road. And then people
Right.
look back and say, what is wrong with that brand X system? It's always going into alarm or always, giving me troubles. Well, it might be because how it was treated while you were doing
Yeah.
your remodeling or your new construction. And some other things, where we locate the devices is important. If they're too close to showers, do I have steam coming out of areas that could be affecting that? So now this is chapter 29 now. So now we're in a hotel, and the smoke alarm inside the room is a device that's there just to alert the occupants in that room. We still have to test them. If they have secondary power batteries, they got to be replaced. And a lot of times we, like Frontier Fire, will also do that work for hotel owners, dormitories of the like. So a smoke detector is a device that connects to a fire alarm control unit, but a smoke alarm is a device that has everything encompassed in one package. It's got the detector, it has a power supply, and a notification appliance, and we call those smoke alarms. Like what we typically have at our homes. So those are governed by Chapter 29. Chapter 29 is our household chapter, household single station, multi-station, household fire alarm systems. So here in Chapter 29, 834(6), smoke alarms and detectors shall not be installed within 3 feet of the horizontal path from a door to a bathroom containing a shower or a tub, unless listed to do that, because it's been a problem. People open up the showers, as you know, steam comes out, and for our photoelectric smoke detectors, you have a beam of light that's coming out, infrared light, and you have some type of a receiver, and you're looking for something to reflect that light into the receiver, whether it's smoke, dust, dirt, steam, anything that it's able to see and reflect that light causes us that unwanted alarm. And that's what we're trying to avoid here. Some of the tools that we get into, Aaron, I know you're all about kind of the state of the art and using tools to make systems better, but there's electronic based servicing tools that we can start to take advantage of in our industry. Excuse me. So what NFPA 72 saw was this trend coming. And they said, okay, we need to address this to allow the use, but to allow the use properly. So they said in code, let's call it automated testing in Chapter 14 and 2.7. And if the automated testing can provide the equivalent means, the same way of testing the device as it states in the table for the frequencies, 14.422, and you do it as often as required, in 14.4.5, you shall be permitted to comply with the requirements of this chapter. So, for example, Aaron, I know your company, you sell a product that has a horn, a strobe, and a speaker that are able to do automated testing, right? So the device can activate the horn sounds, the fire alarm can see that with the transducer inside that horn and recognize that the horn actually worked. Well, when I do that, and I can log if a device failed, failure of a device of an automated test results in a trouble in a visual at the control unit, I don't need to physically go to that device to listen for its operation. I still got to do a visual inspection of the device. But that's one example where automated testing is coming into play. We also see the exact same language in NFPA 25 for sprinkler systems, with some states in the Union, in the United States, we can't flow water all the time. Their water is a precious commodity, a precious resource. So there have been methods where you could take the water flow switch, put a U around it, piping, and a motor, and activate that motor, cause water to spin around past that water flow switch, verify that the flow switch works, and it complies with NFPA 25's testing. So that is an automated test. Once a quarter, once a year, once semi-annually, whatever it has to be, the fire alarm system can instruct that motor to turn on, know that we're in testing mode, watch for the water flow switch to activate. That's an automated test. So we're seeing this more and more in the industry, and I think it's a good thing in many respects. I think automated testing of a lot of the equipment that I see out there today is actually better than having somebody stand out there at the device and doing the test. And I can do this now instead of doing it once a year. I can do these automated tests once a week if you want. And now the reliability of your system can really, really shoot up. So we can take advantage of this in a good way. And I know your company offers a lot of these services, Aaron.
Yeah, absolutely. It's very beneficial to both us as a service provider as well as the end user. It makes it a lot easier, a lot more reliable. And we are an authorized dealer for AutoCall, Johnson Controls product, that provides an automated testing opportunity for the systems to have the automatic testing and self-test systems when it comes to both notification as well as the initiating devices.
Yeah, fantastic. And we get into fire extinguisher maintenance here as we kind of wrap it up. NFPA 10, standard for portable fire extinguishers, how we need to test those. And you need to go and look at your extinguishers once a month. It requires that inspection. 24% of extinguishers inspected annually are not in the proper location. They got removed, they got taken down while people were doing something, maybe vandals got to them. You know, it's just amazing the amount of extinguishers that we come into contact with in our annual inspections that are issues. 26%, a quarter of all extinguishers inspected annually are inoperable due to low pressure. 90% of occupancies mandated to do their monthly inspections do not do them. And that's something that NAFED has done some research and has proven out, and it's kind of a shame. You know, when you walk around in your own lives and you go to a store, a hotel, just take a glance at the fire extinguisher and look at the tag. That tag is supposed to have markings on it, you know, once a month. There's technologies, and I know Frontier, you offer this as well, where we can electronically monitor these things. They can connect to the fire alarm system, and for the monthly inspection, as you know, Aaron, you got to be able to verify the gauge is in the proper pressure area. You've got to verify the device is placed where it needs to be placed, and that the device is not blocked. You do the 3 of those once a month. You sign off on it, and you move on. Well, we do this. We can do all of that and more with our service option connected to your fire alarm system. I can have an ultrasonic sounder to prove that, or to test out every few hours that nothing's blocking the device. This quick connect or quick disconnect goes to the pressure gauge, and I can tell that the gauge is in the right position and that the extinguisher must be there. And if it gets removed, that breakaway comes right off very easily, so doesn't hinder the operation. But then it sends a signal to the fire alarm. The fire alarm sees the extinguisher's been removed, causes a signal at the system, can alert first responders to go and investigate what's going on. So these electronic monitoring of extinguishers was added in the 2007 edition of NFPA 72, as well as NFPA 10. So it's now something that's been recognized and used in a lot of places throughout the code in the United States. Easier to service by design. When we look at our notification appliances, Aaron, and you talked a little bit about this earlier, appliances that are difficult or inconvenient to test may not be tested. You know, when I look at horns or speakers in a hospital, for example, you know, when's a good time to test a fire alarm horn or speaker in a hospital? Never. They don't want you to make any noise. But if I could go out into the hospital nursing home and say, could I just sound all the devices for just a couple of seconds? I can test every device and let you know which one's passed and which one's failed. And a lot of times people will say, okay, you can sound them for a couple of seconds, but that's it. Great, I can go out and I can verify all of the devices function or didn't, and which ones using this this method. And Aaron, I know we talked a little bit about, you can even do this in the middle of the night. I have a business occupancy. They don't want any horns or anything going off in my office building. Well, how about at 2 o'clock in the morning? All the devices can test themselves, and then when I come in the next day, I can have a report whether or not they passed or they failed. Smoke detector sensitivity, Aaron, with your fire alarm control units that you offer, they can tell you now what devices are dirty or almost dirty. So that as I go to a facility, we don't have to clean a clean detector, find out which ones are getting close to being dirty and go clean those. And NFPA 72 recognizes control equipment. Here are the third bullet down in the table 14422. Listed control equipment arranged for the purpose. If your smoke detector control unit arrangement is listed to do this functionality, I no longer have to do individual sensitivity testing at the device. The control unit can do it for me. And duct detector monitoring. This is something we came out with a little bit ago. And you look at duct detectors are way up high. They got to be serviceable. And not everybody has a lift or has a high ladder, or is it safe sometimes for an employee to get up there? So instead of having devices traditionally mounted way up high, you know, like this, what if we brought them down low and we're able to have a a test box that's mounted low and then have the sampling points up high. So that's another offering that's available. So I know we're running out of time, Aaron, but with that, if there's any questions or things that you'd like to discuss further, I'd be happy to do them.
Yeah, I think we hit on a lot of great points, Rodger. I appreciate all the time you took to go through these topics, and I'm sure at this point, with our discussions we have with our customers and clients, when we have these conversations regarding some of their concerns, we could definitely bring them back and go over them anytime. And some of the points that maybe we could highlight when it comes to some of the importance of testing, the requirements of making sure that you're using the right service provider that are going to meet the needs of the local AHJ to make sure they are code compliant, concerns during construction, and of course making sure that you're easily and capable of testing your devices when need be. So thank you, Rodger, and thanks to all of you for investing your time today to learn more about fire alarm testing and inspections. If you have any comments or questions, feel free to email me directly at asolomon@frontierfireco.com. That's asolomon@frontierfireco.com. Also, if you have an idea or for a topic you'd like to learn more about, feel free to make a suggestion, and we'll try to include it in one of our future presentations. Take care and be safe. Thanks, Rodger.